Section 2.5, Matrix Inverses. An inverse of a matrix is similar to finding the reciprocal of a real number. We're going to use matrix inverses to solve matrix equations. So the following is what we call the identity matrix. So notice that the diagonals are all ones and everything else is zeros. The identity matrix works when we have square matrices, so 1 by 1, 2 by 2, 3 by 3, 4 by 4, etc. You can get as large as we'd like. Recall that if we multiply 5 by its inverse of 1/5, we will get 5 times 1/5, which is 1. This is known as the identity property. The same is similar if we multiply a matrix by its matrix inverse, we will get the identity matrix above. So multiply a matrix by its matrix inverse, we will get the identity matrix, so one of the above items depending upon how big we start with. Note that the matrix inverse is represented by a equals by a to the negative first power. So let's find the inverse of this matrix, 1, 2, 3, 0, negative 2, 0, 1, negative 1, 0. So we first need to put it into augmented matrix form with its identity matrix on the right hand side. So it'll look something like this. So our goal is to get on the left hand side the identity matrix, and then something left over will be on the right hand side. So they'll almost flip-flop in a way. We will end up with fractions in the end, but we won't actually have to work with fractions until the very end. So be patient. I will have to stop and erase at times because we have a few steps that we have to tackle. So if I need to have zeros in the 2 and the 3 space, I'm going to multiply my top row by negative 2 and then add it to my middle row. So negative 2, 0, negative 2, negative 2, 0, 0. Add that to my middle row, which I'm not multiplying by anything. 0, negative 2, negative 3, negative 2, 1, and 0. My new middle row is 0, negative 2, negative 3, negative 2, 1, 0. And my bottom row we haven't done anything with, so we'll just leave that as is. I need a 0 in the 3 space, so I'm going to multiply my top row by negative 3 and add it to my bottom to replace my bottom. So that will give me negative 3, 0, negative 3, negative 3, 0, 0. Adding that to my last row, we'll end up with 0, 0, negative 3, negative 3, 0, 1. Okay. We now need to get our very last column here. We need to have a 0 in the 1 spot and a 0 in the middle negative 3 spot. So it looks like I need to multiply my top row by 3 and add my bottom row to my top row. So 3, 0, 3, 3, 0, 0. Adding that to 0, 0, negative 3, negative 3, 0, 1. We end up with 3, 0, 0, 0, 0, 1 as my new numerator here. Or not my new numerator, my new top row. Alright, so now it looks like I need to multiply my middle row by -1 and add my bottom row to my middle row to replace it. So 0, 2, 3, 2, -1, 0. Adding my bottom row. 0, 2, 0, -1, -1, 1. So I'm going to replace my middle row now with this. I'm going to stop and erase at this point so we can continue on. Right now we just need to get the 1 and the top right side into a 0. So I'm going to multiply my top row by 3 and add my bottom row to my top row to replace it. So 3, 0, 3, 3, 0, 0. That should be 1. Alright, now the final step, we need to get our diagonal into 1s. So I'm going to have to divide my entire top row by 3, divide my entire middle row by 2, and divide my bottom row by -3. This will get me 1, 0, 0, 0, 0. Well, 1 divided by 3 is 1/3. 0, 1, 0, -1/2, -1/2, +1/2, and 0, 0, 1, 1, 0, -1/3. So we got our diagonal into 1s, and this part here is considered our inverse, and we would write it something like this. A to the -1 is equal to 0, 0, 1/3. And you'll notice fractions here. It's okay to have fractions. They're very common to have fractions. But this would be our inverse. So let's try another one. Again, these are quite a few steps, so bear with me and we'll get through them together. So we'll first write the augmented matrix, get with the identity matrix. And we'll start getting the zeros where we need them. So I need to get the 1 and the 3 in the first column there into into zeros. So I'm multiply my my middle row by -2 and add my top row to my middle row to replace my middle row. So I'm not going to change anything in my top row, so I'm just going to leave it as 2, 3, 1. But when I multiply my middle row, we get -2, 4, 2, 0, -2, 0. So let's add them. We'll get 0, 7, 3, 1, -2, 0. So we'll replace our middle row we didn't change our bottom row, so we'll just leave it as such. Alright. Now we need to replace this 3 here on the bottom left-hand side with a 0. So I'm going to multiply my top row by 3 and my bottom row by -2. One needs to be a negative, as we know, so when we add them together, they cancel. And I'm going to add my top row to my bottom row again. So if I multiply my top row by 3, we get 6, 9, 3, 3, 0, 0. My bottom row by -2. Adding them together, we'll get 0, 3, -1, 3, 0, -2. Alright, now we need zeros above and below the 7. So I'm going to multiply. We notice our top and our bottom are already the same number, just one needs to be negative. So I'm going to multiply my bottom one by -1 and add it to my top row to replace my top row. So 2, 3, 1, 1, 0, 0. We're not multiplying that by anything. Multiplying my bottom row by -3. We'll end up with 2, 0, 2, -2, 0, 2. So that will be my new top. Alright. Now I need to get rid of my bottom 3. So if I look at 7 and 3, their least common multiple is 21. So I'm going to multiply my middle row by 3 and my bottom row by -7. And if I add them together to replace the bottom row, we'll get 0, 21, 0, 3, -6, 0, so 0, 21, 7, -21, 0, 14. So 0, 0, 7. Alright, hold up, guys. I should have a 3 here and a 3 here. I don't know why I just replaced it with 0. It shouldn't have been replaced yet. So this should be 9. Which then in turn would make this part here 16. There we go. -18, -6, and 14. So this is going to replace my bottom row. At this time I'm going to erase and then we'll continue on. So I replaced our bottom row with 0, 0, 16, -18, -6, and 14. So now we just need to get the 2 and the 3, kind of in the middle there, into zeros. So I noticed that with 2 and 16, if I multiply my top by -8, we will get to 16 and add it with our bottom to get rid of the 0 there. So if we multiply, we'll get -16, 0, -16, 16, 0, -16. Add that to our bottom row. And we'll end up with -16, 0, 0, -2, -6, and -2. So that becomes our new top row. Everything else will stay the same. So in that 3 position, I need to get rid into a 0 there. So if I look at 16 and 3, their least common multiple would be 48. So I'm going to multiply my middle row by 16 in my bottom row by -3 and add them together to replace my middle row. So 0, 112, 48, 16, -32, 0. Multiplying my bottom row by -3, so 0, 0, -48, 70, 70, 54, excuse me, +18, -42. So my bottom row is 0, 112, 0, 70, -14, -42. So that will be my new middle row. And we didn't change anything in the bottom row. So our last step is to get our diagonal here into ones. So to do that, I'm going to divide my top row by -16, divide my middle row by 112, and divide my last row by 16. So that will give me 1, 0, 0. Again, we're going to get fractions, so -2 divided by 16 is 1/8 reduced. -6 divided by -16 is a +3/8, and then another 1/8. So dividing by 112, 0, 1, 0. 70 over 1/12 is 5/8. -14 divided by -112 is -1/8. -42 reduced over 112 is -3/8. And we'll 0, 0, 1. -18 over 16 reduces to -9/8. -6 over 16 is -3/8 reduced. And then 14 over 16 is 7/8 reduced. So again, this part here would be our inverse. So the inverse of A is 1/8, 3/8, 1/8, 5/8, -1/8, -3/8. And again, it's okay that we get fractions. So we can solve a system A times X equals B using matrix inverses. To solve a system of equations AX equals B, A is the square matrix of coefficients, and A to the -1 exists. X is the matrix of variables, and B is the matrix of constants. We first need to find the inverse of A. Then we'll take the inverse of A and multiply it by B. So how we determine AX and B? So A is the matrix of just the coefficients in front of the letters. So 2, -3, 1, and 5. So we also have X these are just the variables that we're looking for, x and y. And then finally, B is the matrix of the other side of the equation. So we first need to find the inverse of A. So that's our first goal, and then we can do some things with it. So let's find the inverse of A. So we have 2, -3, 1, and 5. Again, we put the augmented matrix here. We need to get the 1's position on the bottom left into a 0. So I'm going to multiply my bottom row by -2 and add my top row to it. So 2, -3, 1, 0. Adding that to -2, -10, 0, -2 gives us 0, -13, 1, -2. We didn't change anything to the top, so we'll leave it as is. We also need a 0 in the -3 position. Since they're both negative, I'm going to need to multiply one of them by a negative number. And if I look at 3 and 13, 39 is going to be their least common multiple. So we'll multiply the top by 13 and the bottom by -3 and add the bottom to the top. So we'll have 26, -39, 13, 0. And our bottom row is 0, +39, -3, +6. So when we add these together, we'll get 26, 0, 10, and 6. Oops. 26, 0, 10, 6. All right, now in order to get, remember we need 1's in our diagonal here, so we need to divide every item in the top by 26 and divide every item in the bottom row by -13. So at this point I'm going to divide, and I'm going to erase part of this. So when I divided the top row by 26 and reduced my fractions, we get 5/13 and 3/13. When I divided my bottom row by -13, we got -1/13 and +2/13. So now that we've got our inverse, we've done this portion. So we found our inverse. So now that we can take our inverse portion and multiply it by b, so we can determine what x is. So we're going to take 5/13, 3/13, and we'll multiply it by 4, 2. So we have a 2 by 2 matrix, and we're multiplying it by a 2 by 1 matrix. These match, so we're going to end up with an answer of a 2 by 1. So remember, to multiply matrices, we're going to take our top row and multiply it by the first column. So we'll have 5/13 times 4 plus 3/13 times 2. That will give me 20/13 plus 6/13, which is equivalent to 26/13. And happy day, 26 divided by 13 is 2. So a nice whole number. And now we'll do the same. We want to take our bottom row times everything on the right. So we'll have -1/13 times 4 plus 2/13 times 2. That will give me negative 4/13 plus 4/13, which is 0/13, and 0 divided by anything is 0. So our solution set is 2, 0. That would solve our system of equations. Now, is this the easiest way to go about solving them? Absolutely not. We could definitely do the Gauss-Jordan elimination. We could do the row echelon method. This is just an alternative way. So now we know 3 ways at which we can solve. We can solve again using the Gauss-Jordan method. We can solve using row operations, or we can solve using the inverse. Let's try another one. Use the inverse of the coefficient matrix to solve the linear system. So we have to identify our A. So our A matrix is 5, 4, 4, negative 3. Our X matrix is XY. And our B matrix is 23 and 6. So we have to find the inverse of A first. And get the left-hand side into the identity matrix. So if I look at 5 and 4, I'm going to need to multiply. Our least common multiple between 5 and 4 is 20. So I'm going to have to multiply my bottom by negative 5, my top by 4, and add them together. This will give us 20, 16, 4, 0, negative 20, 15, 0, negative 5. If I add these together, we'll get 0, 31, 4, and negative 5. Oops, didn't even change it. Okay. 0, 31, 4, negative 5. So now I need to get 4 replaced to 0. So I'm going to need to multiply my bottom row by negative 4 and my top by 31. So we're going to get some big numbers here, which is okay. So 5 times 31 gives us 155. 31 and 4 gives us 124. 31 and 0. So multiplying the bottom row by negative 4, we get 0, negative 124, negative 16, and 20. So 155, 0, 15, and 20. So 155, 0, 15, 20. And we didn't change the bottom row. Now we need to get our diagonal into ones. So remember, these portions needs to be ones. So I'm going to divide my top row by 155 and divide my bottom row by 31 and reduce our fractions. So when I do that, I'll get 1, 0. 15 over 155 is 3 31sts. They both can be divisible by 5. And 20 over 155 is 5 over 31. I'm sorry, 4. 20 divided by 5 is 4. Oops. That will help. Alright, in our bottom row, we will have 0, 1, well that can't be reduced, so 4 over 31st, and negative 5 over 31. Alright, so at this point we now have our inverse, and we can multiply our inverse with our numbers over here so that we can find the solution set. And that's what I'm going to do on the next screen. So I'm going to erase some stuff and we'll come back. So our inverse matrix was 3, 31, 431, 431, negative 531. And we want to multiply that by 23 and 6 here. So again, we have a 2 by 2. We're going to multiply that by a 2 by 1 so we can multiply since their middles match. And we're going to end up with a solution set of another 2 by 1. So we're going to multiply our top by the first column there. So we'll have 3/31 times 23 plus 4/31 times 6. This will give us 69/31 plus 24/31, which is 93/31, which can evenly divide into 3. And now we can do the bottom by the left. So we have 4/31 times 23 minus 5/31 times 6. So 92/31 minus 30/31. And we subtract, we get 62 divided by 31, which comes out to be 2. So our solution set is 3, 2. Now, again, this isn't the easiest way to accomplish this solving of systems of linear equations, but it's definitely an alternative way. What happens if we aren't able to find the inverse of a matrix, which is completely possible? So if we're unable to find the inverse, then the system either has no solution or it has infinitely many solutions. And the only way to determine is use the Guass-Jordan elimination method. So let's say we have an electronics company produces transistors, resistors, and computer chips. Each transistor requires 3 units of copper, 1 unit of zinc, 2 units of glass. Each resistor requires 3, 2, and 1 units of the 3 materials, and each computer chip requires 2, 1, and 2 units of these materials, respectively. How many of each product can be made with the following? 810 units of copper, 410 units of zinc, and 490 units of glass. So let's write a 3 by 1 matrix for the amounts that are used. So this is going to be our B matrix. So we're specifically looking at 810 for copper, 410 for zinc, and 490 for glass. So this is what our equations are equal to. So this is the last one we're going to multiply by. Let the 3 materials represent a 3 by 1 matrix with entries A. Write a matrix equation that can be solved for X using the given matrix and the matrix from part A. So we need an A matrix. And our A matrix is going to first deal with copper, zinc, and glass. So the copper, if you look back on the previous page, is 332 for each item, 121 for each item, and 212 respectively for each item. We're going to let our X matrix be A, B, and C. The previous page we had the B matrix for what we're specifically looking for: 810, 410, and 490. Let's going to solve the equation from part B to find the numbers of transistors, resistors, and computer chips that can be produced. So I'm going to use inverse matrices to help solve. So we have to write our 3, 3, 2, 1, 0, 0. And we're going to have to find the inverse. So let's multiply the top row by -3 and add it to our middle row. Excuse me, that wouldn't make any sense. We need to multiply our middle row by -3 and add the top row to it. So 3, 3, 2, 1, 0, 0, -3, -6, -3, 0, -3, 0. This will give us 0, -3, -1, 1, -3, 0. So this is our new middle row. We now need to eliminate the 2 in the bottom left-hand corner, so I'm going to multiply the bottom row by -3, the top by 2, and add them together. 6, 6, 4, 2, 0, 0. -6, -3, -6, 0, 0, -3. And we add them together, we'll get 0, 3, -2, 2, 0, -3. So this is our new bottom row. So now I need to get my 3 in the top and my 3 in the bottom into zeros. But if I look, I can add the middle row to the top row since we don't have to multiply by anything, since they already have the 3 and the -3. And I don't have to multiply anything here as well because they already have So I'm just going to bring that over here so we can see what that looks like. So 0 plus 3. So I'm going to first take, I'm going to add this row to this row here. We'll have 3, 0, 1, 2, -3, 0. Not going to change the middle row. And now I'm going to take the middle row and add it to the bottom row here to replace my bottom row with 0, 0, -3, 3, -3, -3. So we're getting closer. Alright, I just need to get this 1 and -1. I need to get 1 and -1 into zeros. So what I'm going to do is well, if we think about it, we need those to be 0. I need to multiply the top row by 3 and add my bottom row to it. So that would be 9, 0, 3, 6, -9, 0. My bottom row is 0, 0, -3, 3, -3, -3. Adding these, we'd have 9, 0, 0, 9, -12, -3. So I'm going to erase a bunch of stuff at this point. This is going to replace my top row now. So I'm going to reset here and replace my my top row with this 9, 0, 0, 9. So I replace my top row with 9, 0, 0, 9, -12, -3. Nothing else changed. We still need to get that -1 into a 0. So I'm going to multiply that row by -3 and add my bottom row to it. So we'll have 0, +9, +3, -3, +9, 0. My bottom row will be 0, 0, not doing anything different. So when I add them, my middle row is now 0, 9, 0, 0, 6, negative 3. Alright, so we've got the zeros in the right locations. We now need to turn these into ones. So we're going to divide the top row by 9, divide the middle row by 9, and then divide the bottom row by negative 3. So when I do that, I will get, and we're going to obviously get fractions, we're going to get 1, 0, 0, 1, reducing negative 4/3, negative 1/3. Okay, so we're dividing by 9 in the middle, so 0, 1, 0, 0. 6 divided by 9 is 2/3. Negative 3 divided by 9 is negative 1/3. Now we're dividing by negative 3, so 0, 0, 1. 3 divided by negative 3, negative 1. Negative 3 divided by negative 3 is 1, and then 1 again. So now we have our inverse matrix, and we can now multiply by our b so that we can determine how many of each that we have. So I'm going to erase so that we can start multiplying. Our inverse matrix is 1, negative 4/3, negative 1/3, 0, 2/3, negative 1/3, negative 1, 1, 1. And we're going to multiply that by 810, 410, and 490. So we have a 3 by 3, and we're multiplying it by a 3 by 1. So these match. So we're going to end up with our solution of a 3 by 1. So we're going to first start by multiplying our first row by everything on the left using matrix multiplication. So 1 times 810 minus 4/3 times 410 minus 1/3 times 490. We do get some decimals here, but that's okay. So if we'll get 810 minus, we'll have 4 times 410 divided by 3, and that gives me 546.6. So go ahead and use your calculator to verify that 4 times 410 divided by 3 is 546.6. And the same thing, we're going to have 1 times 490, which is 490, and 490 divided by 3 is 163.3. So when we're dividing. So if I were to take 810 minus 54.6 minus 163.3, we end up with 100. Now let's take our middle and multiply it by everything on the left. So we're going to have 0 times 810 plus 2/3 times 410.